Welcome to this brief overview of SB 2030. Today we'll be running through both the structure of the program and the process for compliance. SB 2030 is short for Sustainable Building 2030, and I'll start by noting that it fits within a broader network of related programs that are used at different moments in the lifespan of a building project, from those that are in design and construction all the way through operation. Also note that SB 2030 is part of the Energy and Atmosphere section of the B3 guidelines, so all projects using the B3 guidelines are also required to meet SB 2030. SB 2030 is a progressive energy and carbon reduction program. It is modeled after the National Architecture 2030 effort, customized to better fit Minnesota's buildings, climates, and policies, and expanded to enable a more customizable set of building types. The program requires increasing levels of energy and carbon reduction from the 2003 baseline. The current reduction requirement is at 80%, moving to 90% in 2025. These are net reductions, meaning they can be achieved through a combination of energy efficiency and renewable energy. To meet SB 2030, the project team first sets a project-specific SB 2030 standard early in design and ensures the project budget is sufficient to include energy efficiency and renewable energy. During design, they incorporate efficiency and renewable energy strategies, using energy modeling to ensure they are meeting the energy standard. The SB 2030 review team evaluates the project's documentation to ensure the program requirements are being met. We'll be digging into additional detail in this phase in a few minutes. It's also important to note that the annual energy use will be tracked and reported for the first 10 years of a building's occupancy. If this doesn't meet SB 2030, the owner will need to determine why not and how to correct this. Projects pursuing compliance with SB 2030 are managed through a network of online platforms, the B3 Guidelines tracking tool for submitting documentation, the SB 2030 Energy Standard tool for calculating the project-specific energy standard, and the B3 benchmarking program for tracking operational energy use. The legislation that established SB 2030 requires the performance standards to be achievable cost-effectively. To address this, the SB 2030 team evaluated a large sample of buildings to determine the threshold for cost-effective energy efficiency and renewable energy measures from a societal, participant, and utility perspective, similar to how utility programs evaluate program efficiency. The most recent analysis found this cost-effective limit to be equivalent to a 12-year simple payback. Based on this analysis, this is the current metric used for cost-effectiveness throughout the program. Note that individual projects may choose to implement strategies that are outside of this payback period, but the program is prohibited from establishing a standard that is not achievable cost-effectively. This cost-effectiveness limit, along with the program's current requirement of an 80% reduction, have led to an increased need to go beyond efficiency to also include renewable energy on SB 2030 projects. This graph shows data from over 100 construction projects participating in energy design assistance programs. Energy use intensity is shown on the horizontal axis and simple payback is shown on the vertical axis. So those data points further on the left are more efficient, and lower on the graph use strategies that pay back more quickly. We see the current SB 2030 targets, represented by the yellow line, are still technically possible to achieve based on the maximum efficiency potential modeled by ASHRAE, represented by the red line. However, they are approaching the cost limitations of the market based on this sample, represented by the dashed black line, and may not be achievable within a 12-year payback period. In combination with the ongoing cost reductions we are seeing for renewable energy systems, this suggests that efficiency will need to be paired with renewable energy generation in SB 2030 projects, both to cost effectively meet our current 80% reduction targets and when the program moves to a 90% threshold in 2025. The program design does recognize that some projects will have limited opportunity for on-site renewable energy generation, whether due to site constraints or not being able to find a solution with a 12-year payback. This is addressed within SB 2030's energy hierarchy, which has been adapted for Minnesota from the National Renewable Energy Lab's classification of net zero buildings. Projects are required to first prioritize energy efficiency and on-site renewables. On-campus renewable energy is also accepted for building owners with contiguous property. If the cost-effective limit is reached before getting to 80%, the project has the option of including renewables on a different site within the owner's portfolio. If that is not achievable cost-effectively, the project has the option of purchasing renewable energy certificates, or RECs. Purchasing RECs gives the projects the right to claim renewable attributes of energy that has been produced elsewhere. REC purchases may be coupled with energy purchases, so an owner can purchase both the energy generated from a wind turbine and its environmental attributes, or they can be split. Community solar gardens, for example, typically sell the energy to local subscribers while the RECs are sold separately, often to the utility company. The program looks for a 10-year commitment to these off-site resources. These can be purchased all at once, such as through the purchases of uncoupled RECs from the open market, or over time, such as participating in your utility's green power purchase program. This graphic shows an example of using the SB 2030 energy hierarchy. The first bar on the left shows a typical building in existence in 2003, which is used to calculate the 2030 energy standard, currently an 80% reduction. The current energy code requires efficiency measures that get to about a 50% reduction from a 2003 average building. This example project then uses a combination of beyond code efficiency measures and on-site renewables to get as close to the SB 2030 standard as possible cost effectively, represented by the 2030 on-site target. It then uses off-site renewables to get the rest of the way to the SB 2030 standard. Note that while in-portfolio renewables and RECs are shown here as combined, they are also separate levels in our hierarchy. In practice, though, we are seeing projects use one or the other of these strategies. They typically don't use both. Depending on what efficiency and renewable strategies are available based on project type and site constraints, this energy hierarchy opens multiple pathways to meet SB 2030. The two projects on the left show the preferred pathways, meeting the SB 2030 standard fully on-site. The project in the upper left meets its target using just energy efficiency, while the one in the lower left uses a combination of energy efficiency and on-site renewables. These projects don't require a separate on-site target. The two projects on the right have bumped up against their cost-effective limits and are therefore investing in off-site renewables. The upper project is able to include some on-site renewable development, but needs to purchase RECs to get the remainder of the way to its SB 2030 standard. The lower project has a constrained site and is not able to implement any on-site renewables. They're installing renewables on a different site within the owner's portfolio to fully meet their SB 2030 standard. The process for working through the energy hierarchy to meet SB 2030 involves three parts: establishing the SB 2030 energy standard, evaluating on-site measures, and if needed, pursuing off-site renewables. A flowchart walking through this process is available on our website at b3mn.org. It shows the roles and interactions between the project team and the SB 2030 review team. Projects using the off-site renewables need to engage early with the SB 2030 review team in order to ensure the appropriate on-site target is being set. The first part of this process involves establishing the SB 2030 standard for your project. Once the project has been set up within the B3 Guidelines tracking tool, you'll use your project dashboard to access the SB 2030 Energy Standard tool. This tool uses project-specific inputs to produce an energy model that simulates the energy use of a 2003 average building of the same function and operation as the SB 2030 project. An 80% reduction is then taken from that baseline to determine the SB 2030 standard. The energy standard is shown in kBtu per square foot, and the carbon standard is shown in pounds of carbon dioxide equivalents per square foot. These can be thought of as your energy and carbon budgets for the project. To establish these standards, you will need to identify the building type that best represents your project, then use the space assets to characterize the building program. These space asset areas can be considered to be programmatic building blocks. They represent all the components typically found in buildings with that program. For example, an office asset area is modeled with offices, conference rooms, corridors, toilet rooms, and the other ancillary spaces that serve them. So while we need to distinguish between the gross square footage of the office portion versus the warehouse portion of this example building, we do not need to be more detailed than that. This level of characterization has proven to be sufficiently accurate to establish a realistic SB 2030 standard from the project. Space asset areas can be modified from their default assumptions to better reflect actual conditions, such as geometry, schedule, set points, and process loads. These are important to edit early in the design process if the change is likely to significantly impact the building's energy consumption, such as if the area of a building is anticipated to have a much higher or lower airflow rates than a typical area of that type. The second part of this process is the evaluation of on-site measures, both efficiency and renewable energy. Project teams can model the impact of various design strategies within the SB 2030 Energy Standard tool or a different approved tool. The SB 2030 Standard tool includes default costs that are intended to provide an initial input into estimating the cost of energy conservation measures. If you are able to meet the SB 2030 standard with available efficiency and on-site renewable measures, you will submit documentation to the SB 2030 review team once those strategies have been identified. We will confirm the modeling meets the program requirements and report the project anticipates meeting its SB 2030 standard. A couple of important notes at this stage. Projects may choose to use measures outside of the 12-year payback to meet the SB 2030 energy standard. If you are using on-site renewable energy to contribute to meeting SB 2030, the RECs for that resource will need to be either retained or replaced. Some utility programs provide financial incentives for renewable energy development in order for the utility to use the RECs to meet their renewable energy obligations. Since accessing these incentives typically involves the project is giving up the RECs in exchange for this financial benefit, that generation cannot be counted towards SB 2030. There are some programs that allow the building owner to retain the RECs, notably the Demand Credit Rider program, which provides both the RECs and some financial incentive for demand reduction. If the project is not able to cost-effectively meet the SB 2030 standard with on-site resources, you will need to demonstrate that you have reasonably exhausted alternative design options and propose a SB 2030 on-site target. This target should be the energy use intensity resulting from all efficiency measures and renewables with a 12-year payback or less. The SB 2030 review team will review this documentation and may request that additional strategies or cost evaluation be considered before approving the on-site target. Since this process may include some back and forth, it is important that it get started early in the design process. The final decision gets memorialized in an on-site target memo, where the key metrics of the project are documented. The project team can then decide how to best meet the on-site target. It isn't limited to the strategies used to establish the target. For example, the team may decide to exclude a strategy with a 9-year payback in favor of a strategy with a 20-year payback that also provides benefits to, for example, occupant comfort. The last part of this process is the off-site renewable energy requirement, which is the remainder of the energy demand that has not been met with efficiency or on-site renewables. Projects would first evaluate in-portfolio renewable development, again making sure that the RECs are assigned to the SB 2030 project. If that is not cost-effectively feasible, they would then move to obtain RECs to make it the rest of the way there to their SB 2030 standard. RECs need to cover at least 10 years of the building's energy use, though there's flexibility in how this is achieved, such as an annual procurement based on actual energy use or an upfront purchase based on estimated energy loads. However, it is critical to ensure that the energy sources align with the state's legislative definition of renewable energy. This includes solar, wind, and small hydro. Using biomass will require an in-depth review of both its carbon intensity and whether the specific resources used can truly be characterized as renewable. Hydrogen is only generally acceptable if derived using from these renewable sources. One approach to off-site renewable energy procurement is to invest in renewable energy development. However, it is critical to ensure the project obtains the RECs, the renewable energy attributes of the energy being produced, not just the energy. In fact, the energy associated with the RECs does not need to be purchased by the project. Subscriptions to community solar gardens typically include the energy generated but not the RECs, so this is unlikely to be accepted as a source for off-site renewables. Another option is to purchase RECs from the open market, either upfront for the 10-year period or through ongoing procurement. The primary market for RECs are those that participate in the Green E program, so that may be a useful starting point. Alternatively, many utilities offer green power or green tariff programs, which have their own rate structures applied on monthly utility bills to retire RECs on behalf of subscribing customers. These programs sell renewable energy that is produced on top of what is being required to meet Minnesota's renewable portfolio standard, so the renewable energy requirement is not being double counted. Compliance with the off-site renewable requirement can be documented to the SB 2030 review team through a signed purchase agreement or other verifiable commitment that enough RECs will be credited to the building to offset the required energy use for a period of 10 years. After SB 2030 projects are constructed, their actual energy use must be tracked annually within the B3 benchmarking program for 10 years. On-site renewable energy generation and REC purchases can be tracked within this system, and recent updates allow the ability to allocate portions of shared off-site resources to different buildings. Monitoring energy use through B3 benchmarking, especially in comparison to the building's predicted energy use intensity, can help building operators identify opportunities for operational efficiency improvements. If the building doesn't beat SB 2030 in operation, the owner will need to develop and implement an SB 2030 Energy Efficient Operations Manual. This manual helps reduce energy waste by defining tasks to ensure that each significant energy-consuming device uses only as much energy as needed to serve its intended function. A couple of final program notes. There are several alternative compliance paths for SB 2030 for unique project types. The small building method for projects under 20,000 square feet keeps the hierarchy for on versus off-site measures, but provides a prescriptive approach to what efficiency strategies are expected, enabling the on-site target to be established more quickly. There's also a specific process for wastewater treatment facilities. Due to the high process loads in these buildings, a different approach is used for SB 2030 compliance. That concludes this overview of the SB 2030 program. Please contact us at guidelines@b3mn.org if you have questions about the program or would like any assistance getting started. Thanks.